Let's answer question number 14. Let's start with A. We need to complete the following reaction, and we also need to identify the reaction as SN2, SN1, E2, or E1. Okay, when you are doing this, you need to take a look at what type of haloalkane you have. That should be the first step. So this is a primary haloalkane. And because of this, then you know that the SN1 and the E1 cannot happen. And the reason for this is because for SN1, E1, the first step is the formation of the carbocation. And because it's a primary haloalkane, we know that we cannot form a primary carbocation. It's not stable. So SN1 and E1, those options are out. Okay, next. Then let's take a look at what type of nucleophile or base we have. And what I like to use is the flow chart that is found on page 413 when you are deciding what type of mechanism you will have, SN1, E1, SN2, E2. All right, so the way it works is decide the type of haloalkane that you have, and we have a primary. So let's take a look at this. The first question here, this first block, it says, is the nucleophile slash base a strong base and hinder? Okay, let's answer that question. Is it yes, no, the answer for this question. What is our nucleophile? We have CH3, CH2O, and A. This is sodium ethoxide. On the exam, you may see this just with the line formula like this. That is one way that you can see it's the same thing, or you can view it as this, or just having just the ethoxide. Another way that you could view this is NaOET. That means that ET that you have two carbons, 1 and 2. Okay? Just be familiar that you can see any of these ways and it means the same thing. So let's take a look at the base that we have here. Let's see if it's a strong base. Okay, for you to know if it's a strong base, use the guideline that says take a look at the conjugate acid. What is the conjugate acid of this base? The conjugate acid will be just adding this H here. And then take a look at the pKa. This is ethanol. So the pKa of ethanol is about 16. So this is above the pKa of 11. That means this base is a strong base. Okay? Then, the answer to this question, what will be the answer to this question? Let's read it again. Is the nucleophile slash base a strong base? Yes, it is a strong base. And hinder, but it is a strong base, but it's not hinder. It's not bulky. It's not big. It's a small base. So let's go ahead and answer no. Then, is the nucleophile base a good nucleophile? And you can use the table that is found on your book. I mentioned that table in one of the questions for chapter 9, problem set 1. So let's take a look. Let me see what page is this table at. This is on page 393, table 9.7. And this table divides the nucleophile into good, moderate, and poor nucleophiles. And if we take a look at the example that we have ethoxide, which is just falls into the RO with the negative charge category right here. So that is classified as a good nucleophile. So the answer to this question, is the nucleophile slash base a good nucleophile? Then the answer is yes. And we see that we have the substitution product via the SN2. So we can do a prediction that our major product will be the substitution. But we could have both. We would have the minor product be the elimination product due to this base being a good, strong base. Then you will have the E2, but the SN2 will dominate over the E2. So if the question is asking you what will be the major product, then you can go ahead and say the SN2. For the SN2, we know that what we will do is we will substitute the halogen with your nucleophile. And your nucleophile is this base right here. That is nucleophile. So count your carbons. You have how many carbons? You have 1, 2, 3, 4 carbons. So at the end you will have 1, 2, 3, 4, but now you will have oxygen. This oxygen is this oxygen that you have here. How many oxygens, how many carbons do you have attached to the oxygen? You have 1 and 2, so 1 and 2. So this one will be your major product. The minor product, well, is the elimination. Again, 1, 2, 3, 4 carbons. 1, 2, 3, 4, and then just have the double bond on this location. And this is the E2 product. This is the SN2 product. And this one is the one that is predicted to be the major product.